Good morning students and welcome again in my educational channel Masoom tutorials. Today we are going to discuss different terms related to optically active compounds. First we are going to see the definition of optically active compounds. Okay, so the optically active compounds are such compounds that rotates the plane polarized light when the light passes through such compounds. Okay, and depending on the rotations, depending on the direction of rotation, the optically active compounds can be divided into two types: declaratory, that is known as D form, and laboratory, that is known as L form. And D form, again the definition of dextrorotatory is the compounds that rotates the plane polarized light in clockwise direction is known as dextrorotatory compounds, and the optically active compounds that rotate the plane polarized light in anti-clockwise direction is known as laboratory compounds. In dextrorotatory compounds, the angle of rotation is represented by placing the plus sign before the angle of rotation, and in laboratory the negative sign is placed before the angle of rotation. Okay, and the angle of rotations that is done by dextrorotatory or laboratory compounds is measured by an instrument known as a polarimeter. Optical isomers are two types, dextrorotatory and laboratory, and the optical isomers are such compounds that have asymmetrical carbon, and hence optical isomers are also known as asymmetrical carbon compounds. Okay, and again what is asymmetrical carbons? So the compounds in which the all constituent attached to the central carbon atom is different, then such carbon is known as asymmetrical carbon, and such compound is known as asymmetrical carbon compounds. Okay, for example, butane 2-ol. This is the example of asymmetrical carbon compounds. Here we see that this carbon constituent here it is ethyl, this is hydroxyl group, this is methyl group, and this is hydrogen ions. So they are different four constituent attached to this central atom. So this carbon is asymmetrical carbons, and hence this compound is asymmetrical carbon compounds, and as a result butane 2-ol is a optically active compounds. Okay.